Hello students, I'm coming to you with the next video lecture on Chapter 4, which covers normality of distributions. This is the second video lecture in this series. In the last video lecture, we discussed the following concepts: normal distributions, standard normal distributions, and the theory underlying standard normal distributions, which is referred to as the 68, 95, 99.7% rule. We also discussed the concepts of skewness and kurtosis. We concluded the video lecture by discussing several tools that we can draw upon in evaluating the normality of distributions. In this video lecture, we will discuss the concepts of z-scores and percentile ranks. At the end of this video, I will invite you to check for your understanding of these concepts. In terms of learning objectives, by the end of this video, you should be able to understand and explain the concept of z-scores and their purpose. Apply the concept of z-scores in order to convert raw score distributions into z-distributions. Understand and explain the concept of percentile ranks. And finally, apply the concept of percentile ranks in order to compare differing distributions of data. Now let's discuss in greater detail the concept of standardizing a distribution, which involves converting raw scores into z-scores. In the last video lecture, we discussed the fact that the normal distribution is based on the original raw scores that make up the distribution of a variable. On the other hand, the standard normal distribution is based on z-scores. For every raw score in a distribution, there is a corresponding z-score. These z-scores form their own separate distribution that we can refer to as the standard normal distribution or the z-distribution. A z-score indicates the number of standard deviation units a corresponding raw score is above or below the mean. By calculating the z-score for each raw score in a distribution, we transform the original distribution of raw scores into a distribution with an identical shape, but with a mean of 0 and a standard deviation of 1. Here is the z-score formula, where x equals the raw score, x bar equals the mean, and s equals the standard deviation. Now let's compare the raw score distribution and the z-score distribution for the variable emotional balance. Here is the raw score distribution for the variable emotional balance. Now, here is the z distribution for the same variable emotional balance on the right. Notice that for every raw score on the left, there is a corresponding z-score on the right. Here are the two distributions, the original raw score distribution and the z-distribution. As you can see, the two distributions are identical, except for their means and standard deviations. The original raw score distribution has a mean of 23.18 and a standard deviation of 6.155. On the other hand, the z-distribution has a mean of 0 and a standard deviation of 1. As mentioned previously, z-score distributions always have a mean of 0 and a standard deviation of 1. Now let's practice calculating z-scores for this variable. We are going to calculate the z-score for the first score in the distribution. Here is the answer. But on the next slide, we will walk through the steps for how we arrived at this number. Let's say you have a client that has a raw score of 26 on the emotional balance scale. The average on the scale is 23.18 and the standard deviation is 6.155. Thus, their z-score would be 26 minus 23.18 divided by 6.155. In other words, the z-score is 0.458 or 0.46 standard deviation units above the mean. Now let's compare the raw score distribution and the z-score distribution for the variable social support. Here is the original raw score distribution for the variable social support. Here is the z-score distribution for the variable social support to the right. Again, notice that for every raw score on the left, there is a corresponding z-score on the right. Here again, the two distributions are identical, except for their means and their standard deviations. The original raw score distribution has a mean of 27.33 and a standard deviation of 5.398. On the other hand, the z-score distribution has a mean of 0 and a standard deviation of 1. Again, z-score distributions always have a mean of 0 and a standard deviation of 1. Now let's practice calculating z-scores for this variable. We are going to calculate the z-score for the first score in the distribution. Here is the answer. On the next slide, we will walk through the steps for how we arrived at this number. Let's say that the same client scored a 29 on the social support scale. The average on the scale is 27.33, and the standard deviation is 5.398. Thus, their z-score would be 29 minus 27.33 divided by 5.398. In other words, their z-score on this scale would be 0.039 or 0.31, standard deviation units above the mean. Now let's discuss in greater detail the purpose of z-scores. Z-scores allow us to make direct comparisons of two different distributions of data, even if they are measured on separate scales. Since we have converted the variables of emotional balance and self-esteem to z-score distributions, we can now make direct comparisons of these two different distributions. Now let's discuss z-scores and corresponding percentile ranks. Every raw score has a corresponding z-score, and every z-score has a corresponding percentile rank. Once we have our z-score distribution, we can pinpoint the exact percentile rank at which each z-score falls in the distribution. Here are some general rules of thumb regarding z-scores and corresponding percentile ranks. For example, a z-score of 1 always falls at the 84th percentile, while a z-score of 2 always falls at the 98th percentile. Here is the z-score table. This table is much more nuanced than the general rules of thumb that I just mentioned. It allows us to pinpoint the exact percentile rank for any given z-score in the distribution of a variable. In the red boxes are the percentile ranks that correspond to the z-scores that we just calculated for emotional balance and social support. We find the beginning digits of the z in the vertical column on the left. Then we find the last few digits of the Z in the horizontal rows at the top of the table. For example, the Z-score for the variable social support is 0.309 or 0.31. So I found 0.3 in the left-hand horizontal column. Then I moved across to 0.01 in the vertical column at the top of the table. So the exact percentile rank for the score 0.31 is 0.6217. In other words, this particular Z-score falls at approximately the 62nd percentile rank in the distribution. I repeated these same steps for locating the percentile rank for emotional balance, which is pictured here. So for this client, their Z-score for emotional balance falls at the 68th percentile rank. And their Z-score for social support falls at the 62nd percentile rank. Now let's talk a little bit about interpreting percentile ranks. Although these two variables are measured on entirely different scales, standardizing the distributions made it possible for us to compare them. Interestingly, although these are two different scales, the client's scores fall at similar percentile ranks. One score falls at the 62nd percentile rank, and the other score falls at the 68th percentile rank, which is about here on the standardized normal distribution curve. This is about average relative to other clients. So in summary, in this video, we discussed Z-scores and percentile ranks. Specifically, we discussed normal raw score distributions versus standard normal distributions. We also discussed the process of converting raw score distributions into corresponding Z-score distributions. In addition, we discussed the process of calculating Z-scores. And finally, we ended this lecture by discussing how to go about locating and interpreting corresponding percentile ranks for Z-scores within a distribution of data. This is the point at which I invite you to check for your understanding of these concepts. You can do this in one of three ways. You can simply complete this form on the left and click submit, or you can copy and paste this link in your browser or scan this QR code with your cell phone in order to complete this survey. Here's a crash course video on Z-scores and percentile ranks that you might consider watching in your own time. I hope this has been helpful, and I look forward to seeing you in the next class.